Okay, let's look at the pizza problem. Okay, we're going to look at the pizza problem. They're giving you the number of toppings and then the cost for the pizza. Okay, so apparently if you get one additional topping, and I'm assuming tomato sauce and cheese is already on the pizza, but for one additional topping, you pay $11.25 for the pizza. For two additional toppings, you pay $12.50 for the pizza. Okay, for three additional toppings, $13.75. Okay, and so on. Okay, we want to find the slope and explain it, y-intercept and explain it, write the equation, and then answer the question. Okay, before we do this, we've been talking about x and y all the time, right? Okay, we had like slope of a data table would be change in y over change in x. Okay, instead of y is always on the right side of your data table. X is always on the left side of your data table. Well, instead of using the letter Y, they wanted you to use a capital C for cost. Instead of using X, they wanted you to use the letter T because toppings starts with the letter T. Okay, so we do that quite a bit. Instead of using X and Y, we use different variables. Okay, so let's first find the slope with labels. Okay, and again, slope is change, and slope of a data table is change in your y values over the change in your x values. Again, y's are on the right, x's are on the left. Okay, so change in y over change of x. I'm just going to look at these 2 points. Okay, to get from 13.75 to 15, okay, we added $1.25. Okay, that's the change in y. Okay, the change in x, to get from 3 to 4, we're adding 1 topping because that's a change in x. So the slope, change in y over change in x. Okay, the change in y is $1.25. The change in x is 1 topping. Okay, use labels so you understand it better. Okay, you can simplify $1.25 divided by 1 to just be $1.25. Okay, so the slope is $1.25 per topping. Okay, now that's the slope with labels. Okay, the slope itself is just 1.25. Okay, but what that means, think about change. Okay, slope is change. What that means is you're going to be charged an extra $1.25 for each extra topping. Okay, you're going to be charged $1.25 extra. So $1.25 charged for each extra topping. Okay, that's just the way I worded it. You could word it a different way. Okay, so that's the slope. Okay, the y-intercept is the initial amount. Okay, slope was change. Slope is change. It changed $1.25 per topping. Y-intercept is initial amount. But be careful. It needs to be the value that corresponds to 0. Okay, to 0, not to 1. Okay, even though the first value you see on this data table is 1125, corresponding to 1 topping. Okay, that's not what y-intercept is. It needs to be the value that corresponds to x equals 0. So I need to figure out what the amount would be on my data table across from 0. Okay, we'll just use the pattern. Okay, if it keeps going up $1.25, up $1.25, up $1.25, if you're thinking backwards, it's going to be going down $1.25, down $1.25. And if you take away $1.25 from 10, if you take $1.25 away from 11.25, you end up with 10. So 10 is really your y-intercept. because it's the y value across from x equals 0. Okay, and what that means, it's going to cost $10 for a regular pizza with 0 additional toppings. So you had nothing extra on that pizza. Okay, that's going to be a charge of $10. Okay, y-intercept is initial amount. Okay, the equation, okay, instead of y right here as the first part of your equation and x right here in front of the plus sign, we're just going to use capital C for cost and T for toppings. But you do it the same way. So the $1.25 goes in front of T, in front of the T, the variable. The 10, the y-intercept goes at the end. Slope is always in front of the variable. Y-intercept is always at the end. And think about this again for a second. Think about what this means. C is cost. T is toppings. So what this is telling us is that the cost of this pizza is equal to $1.25 per additional topping plus the $10 for no toppings, for no additional toppings. Okay, is that starting to make sense? Okay, this equation is telling us the relationship in this situation. Okay, the last question, how much does it cost for 6 toppings? You may prefer to just use the data. Okay, I can keep continuing this pattern. Okay, on the X side, I keep adding one topping, one topping, one topping, one topping. On the Y-axis, or on the Y side, I keep adding $1.25, $1.25, $1.25. So 15 plus $1.25 would be $16.25. And then $16.25 plus another $1.25 would be $17.50. Okay, so you could use the data.
Mr. Criswell, can you please come to the front office? Mr. Criswell?
Okay, but I also want you to know how to use the equation. Okay, if we had y equals 1.25x plus 10, think about what they're giving you. They're giving you 6 toppings. They're asking you how much does it cost. Okay, so they're giving you, oh, I wrote that with the wrong variables, didn't I? Let's do it the way we had it. Okay, they're giving us 6 toppings. Okay, they're giving us T. They're giving us T as 6. Okay, they're asking us for the cost, which is C. So you're going to plug in that 6 in for the topping variable, which is T. You're going to keep the rest of the equation alone. So you're going to have cost equals 1.25 times 6, add 10. Okay, so we don't have to isolate C. Okay, we do not need to isolate the variable because it's already alone. All we need to do is figure out what $1.25 times 6 plus 10 is. Okay, then we got it. Okay, $1.25 times 6. Let's see, that'd be $7.50. And then add 10 to that. And that's going to also give us the $17.50 that we had just by looking at the data. Okay, so it's $17.50 for a 6-topping pizza. Guys, keep me posted if I can help you with this.